Last meeting, we started chapter 7, uniform flow in channel. And I covered very important equation. This equation is very famous among engineers, which called Manning equation. This equation can help you to figure out what is the discharge and what is the velocity in a channel. The velocity equal K divide N R hydraulic radius to power 2/3, slope to power 1/2. If you add area to this term, K divide N area, hydraulic radius to power 2/3, slope to power 1/2, I can figure out the discharge. But the first one, figure out the velocity. Last meeting, we covered many examples. Two of them were, just a reminder, hydraulic radius, which equal area divide weighted perimeter. If you have a circle and this circle is half full, like this, I still can figure out what is the area. It's a half circle. I can figure out what is the weighted perimeter. It's half perimeter of the circle. So I can figure out the hydraulic radius. If the flow is full, the pipe is full, I still can figure out the area. I still can figure out the weighted perimeter. So I can figure out the hydraulic radius, and then I can use this equation or this equation to figure out the velocity or discharge. Last meeting, I told you sometimes we have different situations. If you have a pipe, here is the circle, is the center of the pipe. If you have partial fill, not half and not full, something in between, we have a big issue right now. Why? Because the hydraulic radius equal area divide P. What is the area right now? The area is something not half circle and not whole circle, something in between. How much? I don't know. Also, the weighted perimeter. The weighted perimeter. I don't know what is the length of this weighted perimeter. It's not half circle. It's not full circle. Something in between. So, we have a new technique using this chart. Let's start an example. We have a pipe. This pipe has a diameter 18 inch, and the water depth in this pipe equal 12 inch. What you mean? I mean, I have a pipe. The diameter of this pipe 18 inch. The water depth in this pipe is 12 inch. It's higher than half circle a little bit. We need to figure out what is the area of flow. What this area is. I will show you how can I use this chart. It's very simple, but just you need to understand how can I use it. It's very easy. Just pay attention, please. Pay attention. Anybody can tell me what is the area full? If you assume this circle is full, just assume if this circle is full, what will be the area? By divide 4 times diameter square. Your diameter will be, just a second. Okay, your diameter will be 18 divide 12, convert it to feet square. So the area full will be by divide 4 times diameter square 1.767 feet square. But I'm not looking for area full, I'm looking for this area only. Okay, go ahead and find depth of water divide diameter of pipe. The depth of the current water is 12. The total diameter of this pipe 18. What is the value? 12 divide 18 equal 0.67. Any questions so far? First step, I assumed full flow. Second step, I got the ratio between the water depth and the pipe diameter. The third step, this ratio 0.67. I will open this chart. We have on this side of the chart something called ratio of water depth to diameter. D small divide capital D. One more time, what is the ratio? 0.67. Where is this number? 0.67. I think you are here. Do you agree? Do you agree? Okay. I will go horizontally until which curve you are looking for? Until the curve saying area. Why? Because I'm looking for area. We are looking for this area. So I will look for the curve of area. Which curve? This one. So the intersection between this curve and the horizontal red line is here. Go down. What is this number? Is something around 0.72. 0.72. So the ratio between area required and the area full equal 0.72. The ratio between area required and the area full equal 0.72. So the area required divide area full, when you assumed it's a full, 1.767 equal 0.72. So the final conclusion, area required, which is area partial full, which is area for this area, equal 1.767 times 0.72 equal 1.27 feet square. So the final conclusion is This area equal 1.27 feet square. Any question so far? I will do another example, but any question so far? It's very easy. The first step, please go ahead and assume you have full flow. The pipe is full. What is the area? Second step, what is the ratio between water depth and the diameter of the pipe? From the chart, here is the ratio, depth divide D. Go horizontal. Which curve I'm gonna use? What you are looking for? I'm looking for area. So go ahead and choose the area curve. This curve. The intersection between this curve and the horizontal line is this point. Go down. This value represents the ratio between the two areas. Area required and the area full. Any question? Any question? Is it clear? Because you have to expect one problem in your exam.
Can you repeat the very last step you did? What did you multiply?
Okay. The last step.
Yeah, right there.
Okay. What is the value here? Do you agree it's 0.72? That's right. 0.72 represent what? Area required divide area full. So the final conclusion, area required divide area full equal your number 0.72. Do you agree? 0.72 that you got here is represent area required divide area full. One of you will say, hey, why this number 0.72 did not represent this ratio or this ratio or this ratio? Why you choose area divide area? For one reason, one simple reason, because I used the curve for area. So this number 0.72 will represent ratio between area and the area full. So the final conclusion, area divide area full equal 0.72. Can you remind me what was the area full? Area full means you assumed the pipe is full. The area was 1.767, which equal pi divide 4 diameter square. So I removed the area full and I bought the area full 1.767. We still have area required divide 1.67 equal 0.72. What is the value of area required? Your area required equal this one times this one. That makes sense? Is it clear right now? Is it clear?
Yes, sir. Yes, sir. Thank you. I see what you did now.
Okay. This part is very important. You have to expect one problem in this part. One more example. One more example. We have a pipe with diameter equal 24 inch. This pipe has a diameter equal 24 inch. And there is a water inside this pipe with depth, this depth equal 20 inch. We learned how to figure out this area. That's right? No, I will not ask for the area. I will ask for what is the hydraulic radius. What is the hydraulic radius? Okay, we have 3 steps. We have 3 steps. First step, assume full flow. I'm sorry, what you mean by assume full flow? I will assume this pipe with the diameter 24" is full. So what is the area right now? By divide 4 times 2 feet square. 24 feet, I'm sorry, 24" equal 2 feet. Weighted perimeter. What is the weighted perimeter right now? It's full. So the weighted perimeter is the perimeter of a circle. Pi times D. So the area will be pi divide 4 times 4 equals 3.14. The second one, 6.28 feet square feet. Can you tell me what is the hydraulic radius? Full. Guys, remember these numbers for your assumption. I assumed full flow, which is not the case, but I assumed. So the hydraulic radius will be area divided P, your area 3.14, your perimeter 6.28, your number will be, I think, 0.5. Any questions so far? Second step. We are not full. We have partial flow. Your case right now, the actual case is like this. We have depth equal 20. We have diameter equal 24. Can you tell me what is the relationship or what is the fraction? Depth divide D. Yes, I can. Depth equal 20. Diameter equal 24. What is the number? 20 divide 24 equal 0.83. Third step. Use chart. One more time. The depth divide diameter equal 0.83. Where is 0.83? Let me erase this line and this curve. Where is the number? 0.83. 0.83. I think you are here. So I will go horizontal. To hit which curve? Which curve I'm looking for? Okay, go back to the problem. You are looking for what? Hydraulic radius. So we have a curve here called hydraulic radius. Can you see it? This curve is this one. What is the intersection between your horizontal line at 0.83 and the required curve at this point? Go down from this point. What is the value here? Looks like 1.22 or 1.23. So your value, this value, 1.22, represent what? This term. The required hydraulic radius divide the full hydraulic radius equal 1.22. So that means required hydraulic radius divide hydraulic radius full equal this number, 1.22. So the required hydraulic radius, this one is the required one. divide. What is the hydraulic radius when you assumed it's full? Your number was 0.5. Hydraulic radius full 0.5 equal 1.22. Can you right now figure out the required hydraulic radius? Yes, I can. What is the number? 0.61. So if you have a pipe with diameter 24 inch and the water depth is 20 inch, the hydraulic radius will be 0.61. That makes sense? Guys, that makes sense? This point is very important. This point is very important. Please pay attention. One more example. So please, when you put here the value d divide diameter, which curve I'm looking for? Okay, go back to the problem. What you are looking for? If you are looking for area, I will use this curve. If you are looking for hydraulic radius, I will use this curve. Let's try another one. Let's try another example. Okay, let's do one more. We have pipe with a diameter equal 36 inch. So the diameter equal 36 inch, which equal 3 feet. The water depth inside this pipe is 30 feet. 30 inch. The water depth, which is D, equal 30 inch. Given V velocity for this pipe, if it's full, equal 30 feet per second. Can you tell me what is the velocity of this pipe when it's partial full? This given velocity assumed if this pipe is full. This is not the case. The case that this pipe is not full. So what is the velocity for this case? It's very easy. We have 3 steps. First step, assume the pipe is full. So this pipe is full. We don't have more calculation because V velocity full is given 30 feet per second. We don't have more calculations here. Velocity is given full. Second step, what is the ratio between D and the diameter? Depth of water 30 feet or 30 inch. Diameter 36. So 30 divided 36. What is the ratio? 0.83. You are lucky. The third step, use chart. Where is the value 0.83? Here you go. This one, I will go horizontal. Which curve I'm gonna use? Any help? Which curve? Please go back to the problem. What you are looking for? I'm looking for velocity. So which curve I'm gonna use? Curve of velocity. Where is the velocity? Here you go. We have two curves, the solid one and the dash one. We will use the solid one. This curve for velocity. The intersection between this curve and the horizontal line is here. What is the value? Downstairs. 1.01, 02, okay, 1.02, this value 1.02, something like this. Anybody can tell me this value represent what? 1.02 represent what? You are using velocity curve. So this value will represent this ratio. Velocity divide velocity fall. So velocity, required velocity divide velocity fall equal 1.02. Required velocity divide the velocity fall was given 30 equal 1.02. So I can figure out the required velocity. It will be 30.6 feet per second. Any question? Guys, do you have any question? We have 3 steps. We have 3 steps. That makes sense? Looks good? Let's do this example. Let's do this example. Example number 6. Okay, we are looking for what is the area, what is the discharge, what is the velocity. So we are looking for velocity, discharge, area. For this case, what is the case? We have a diameter of a pipe 18. We have water depth 16.92. Okay, we have 3 steps. First step, assume full flow. So we have a pipe with diameter 18 inch. This pipe is flowing full. What is the area? What is the weighted perimeter? What is the hydraulic radius? What is the discharge? What is the velocity? In the case of full flow, I will calculate everything because your flow is full. So you have a problem, looks like this problem, full. And for this problem, we can figure out velocity, discharge, weighted perimeter, area, hydraulic radius, everything, because your pipe is full. Can you? Yes, I can. Go ahead. What is the area? Pi divide 4 time your diameter here is 1.5 feet. So 1.5 square. What is the weighted perimeter? It's a perimeter of a circle. So pi time d. What is the hydraulic radius? Area divide P. Okay, let's go. So pi divide 4 times 1.5 square. This area will be 1.767. Pi times 1.5. This one will be 4.71. The area divide perimeter. It will be 0.375. What is the value of discharge? K divide N, area, hydraulic radius, 2/3, slope to power 1/2. Go ahead and put your numbers. K 1.468. N Manning coefficient is given. Manning coefficient should be given. Manning coefficient equal 0.015. You can assume it, but it should be given. So 0.015. The area of this pipe 1.767. The hydraulic radius 0.375 to power 2/3. Slope is given 1%, so 0.01 to power 1/2. What is the discharge? Wait. 375 to power 2/3. 1.767 by 1.468 divided by 0.015. This discharge is 9 cubic feet per second. The velocity will be, I will divide this discharge by area. It will be 5 feet per second. So guys, from these calculations, I can find the area full, perimeter full, hydraulic radius full, discharge full, velocity full, because I assumed I have full flow. Any question so far? Any question so far? Please let me know. Any question so far? Okay, let's go to the second step. We don't have full flow, we have partial flow. So what is the ratio, or what is the fraction depth divide the water depth is 16.92. The diameter is 18 inch. What is the value? 0.94. Third step, I'm gonna use a chart. Remember, we are looking for area. Let's start with the area. Your value depth divide D is 0.94. 0.94. 0.94. I think we are here. 0.94. So I will go horizontally. Until which curve? Which curve? Okay, we are looking for area. So I will use the curve for area. This one. This intersection will be approximately at 0.9798. So the ratio area divide area full equal 0.97. So the required area divide area full 1.767 equal 0.97. So the required area equal 1.71 feet square. Second, we are looking for discharge. So we are looking for discharge. What is the ratio between Q and Q full? One more time. Depth divide D 0.94. 0.94. Here is the horizontal line. Which curve right now? I'm gonna use the curve for discharge. This curve. I'm going to use this one. This intersection, I'm sorry. This intersection here at something around 1.02. So the ratio between discharge and the discharge 1.02. The required discharge. What is the discharge at full? Do you remember this number? Discharge at full was 9. So 9 equal 1.02. So the required discharge will be 9.18. The third one, we are looking for velocity. Okay. What is the ratio between velocity and the velocity fall? The same value, 0.94. Which curve at this moment? What do you think? Which curve? The curve for velocity, this one. The intersection will be here, something like 1.05. Velocity divide velocity fall. Do you remember what was the velocity at fall? It was 5. Equal 1.05. So I can figure out the required velocity will be 5.25. So the idea for this kind of problem, if you have a pipe and this pipe is partially full, it's not half or full, something in between, we can assume first step that this pipe is full. If the pipe is full, we can determine everything: velocity, discharge, hydraulic radius, perimeter, wetted perimeter, and the area. We can determine everything. Then how can how can I get these numbers for partial flow? It's very easy. Just go ahead and get the ratio between water depth and the diameter. This number 0.94 will intersect with different curves. If you use the intersection for this curve, we can get the discharge. For this curve, you can get the area. For this curve, you can get the velocity. And the same. So I can figure out the ratio for area. If you are using the curve of area, the ratio for discharge, the ratio for velocity, based on what is the curve you are using.